From the dawn of humanity, we've gazed up at the stars, longing to touch the cosmos. But our journey to the heavens began right here on Earth, with the dream of flight. NASA, an agency synonymous with space exploration, has also been a driving force behind a different kind of odyssey, a revolution in aviation. Through daring engineering and relentless innovation, NASA's aircraft have redefined the very limits of what's possible in the air and beyond. Think of supersonic jets ripping through the sound barrier, or experimental planes pushing the boundaries of altitude and speed. These aren't just feats of engineering, they're testaments to the power of human curiosity. In this exploration of NASA's most important aircraft, we'll journey through the history of aviation, marveling at groundbreaking technology, while uncovering the profound impact these aircraft have had on our understanding of flight. Get ready to explore the sky with us, from the edge of the atmosphere to the very edge of the space frontier. Our story begins with a series of aircraft so groundbreaking, so daring, they were dubbed the X-planes. These weren't your typical airplanes designed for commercial flights or leisurely journeys. The X-planes were born from a burning desire to push the very limits of what humans could achieve in the air. They were experimental, radical, and at times even dangerous. But from these high-risk endeavors emerged some of the most significant advancements in aviation history. Imagine the year is 1947. The world is still reeling from the aftermath of World War II, but on the dry lake beds of California, a different kind of revolution is brewing. The Bell X-1, a sleek, bullet-shaped aircraft, prepares for takeoff. At the helm is Chuck Yeager, a young test pilot with nerves of steel and the weight of history on his shoulders. He's about to embark on a mission to break the sound barrier, a feat many believed impossible. The X-1, powered by a rocket engine, blasts off into the sky, pushing Yeager faster and faster. The air around the aircraft begins to compress, creating a wall of resistance. And then, in a moment that shattered expectations and ushered in the supersonic age, the X-1 breaks through the sound barrier. The sonic boom that followed wasn't just the sound of an aircraft exceeding the speed of sound, it was the sound of human ingenuity triumphing over perceived limitations. The X-planes continued to push the envelope, reaching for ever greater heights and speeds. Among them was the X-15, a remarkable aircraft that took us to the very edge of space. The X-15's legacy extended far beyond its record-breaking flights, influencing the design of future spacecraft, including the Space Shuttle. When we think of the Space Shuttle, we envision those awe-inspiring launches, the roar of the engines and the spacecraft majestically ascending into the black canvas of space. But the Space Shuttle was more than just a spacecraft. It was a marvel of engineering that blurred the lines between aerospace design and aviation. This remarkable vehicle, capable of traveling beyond Earth's atmosphere, also possessed the unique ability to return to our planet and glide gracefully to a landing, just like an airplane. The Space Shuttle program, spanning 3 decades, revolutionized our approach to space exploration. This reusable spacecraft, with its iconic orbiter perched atop a massive external fuel tank, became a symbol of human ingenuity and our relentless pursuit of knowledge beyond Earth. At the heart of the Space Shuttle's design lay a fundamental challenge: how to safely return a spacecraft from the blistering speeds of orbital re-entry and land it with the precision of an aircraft. The solution was an intricate system of thermal protection tiles, aerodynamic control surfaces, and a skilled pilot at the helm, navigating the orbiter through the delicate dance of atmospheric re-entry. As the Space Shuttle pierced through Earth's atmosphere, friction would cause temperatures on its heat shield to soar, reaching thousands of degrees Fahrenheit. Yet inside the spacecraft, astronauts worked and conducted experiments in a relatively comfortable environment, a testament to the ingenuity of the shuttle's thermal protection system. The Space Shuttle's ability to land gracefully on a runway like a plane returning from a cross-country flight was a testament to the brilliance of its design. It showcased the convergence of aerospace engineering and aviation technology, demonstrating that the boundaries between these fields were not insurmountable. The Space Shuttle program, though now concluded, left an indelible mark on human history. Chapter 3. The Blackbird soaring at the edge of darkness. In the annals of aviation history, few aircraft captured the imagination quite like the SR-71 Blackbird. Its sleek, black profile, resembling a bird of prey poised for supersonic flight, hinted at the incredible capabilities that lay within. Originally designed for military reconnaissance during the Cold War, the SR-71 quickly transcended its initial purpose, becoming an invaluable tool for scientific research and a symbol of human ingenuity pushing the boundaries of speed and altitude. The Blackbird was a marvel of engineering capable of reaching speeds exceeding Mach 3 or 3 times the speed of sound. At altitudes soaring above 80,000 feet, it could outrun and outmaneuver any threat, its pilots donning pressure suits resembling those worn by astronauts, a testament to the extreme conditions in which this remarkable aircraft operated. But the Blackbird's legacy extends far beyond its military exploits. It became an indispensable tool for NASA, providing scientists with a unique platform for conducting research at the edge of the atmosphere. Imagine soaring high above Earth, the curvature of our planet visible against the blackness of space. The air is thin, the sky a deep, almost unnatural blue. Below, clouds stretch out like cotton candy, while above, the stars begin to twinkle in the early evening sky. This was the domain of the SR-71 Blackbird, a realm where few aircraft dared to venture. From this lofty perch, the Blackbird collected invaluable data on Earth's atmosphere, weather patterns, and even distant celestial objects. Its high-altitude flights provided scientists with unprecedented views of our planet and the cosmos, leading to groundbreaking discoveries in fields ranging from astronomy to meteorology. The SR-71 Blackbird, though retired from active service, remains an enduring symbol of human ingenuity and our insatiable thirst for knowledge. Its legacy continues to inspire engineers and scientists today,